Prvi je i za sada jedini astronaut iz Švicarske koji je radio i za Evropsku svemirsku agenciju ESA i američku NASA-u. 4 puta letio je u svemir. 2 misije bile su istraživačke, dok su druge 2 bile misije servisiranja svemirskog teleskopa Hubble. Tokom svog posljednjeg svemirskog leta proveo je više od 8 sati u svemirskoj šetnji, postavši prvi astronaut Evropske svemirske agencije, koji je to učinio tokom misije Space Shuttle. Kao predsjedavajući Švicarskog centra za elektroniku i mikrotehniku, izučava specijalni laserski sistem LISA, koji ima za cilj otkriti gravitacijske talase u svemiru i dobiti svjež uvid u strukturu crnih rupa i porijeklo svemira. U okviru događaja World Minds, održanog u Beogradu, Claude Nicollier govori za Jazeeru o svojim svemirskim misijama, važnosti daljnjeg istraživanja kosmosa i čemu nas ta otkrića uče i o našoj planeti.
Claude, thank you for finding time for Al Jazeera.
It's a pleasure.
So you're a former ESA and NASA astronaut, actually the first and currently only Swiss astronaut there. And you have been fascinated by space ever since you were a little boy. So did you have something or someone deeply influencing you at that age and shaping you as a future astronaut?
Yeah, I had always a passion for stars, a passion for astronomy, and I had a passion for airplanes also. So in my professional activity, I followed the road of a physicist, then astrophysicist, and then I flew in the Air Force as a part-time activity. So this was in the 60s, so that was the beginning of the space age. You know, the first human being in space was Yuri Gagarin in April 1961. Then we had the Apollo program. So I was fascinated by space as well, but for me I thought, well, it's impossible. This is something the Soviets are doing and the Americans. And it became possible in the mid-70s when we were invited in Europe to participate in the shuttle program. But I had really a deep passion for astronomy and for aviation.
And you got to live your boyhood's dream. You were 4 times in space. How did you feel for the first time when you saw stars and Earth from the orbit?
Yeah, it's an amazing feeling, really. It's something that is hard to describe, and when you show pictures, it's only a small fraction of the beauty of what you see from space. It's really heartbreaking how beautiful the Earth is from space, and also you move at a very high velocity at 28,000 kilometers an hour. You go around the Earth in an hour and a half, and that was fascinating to see the planet Earth as a celestial body. When you're on the surface, you can forget that it is a celestial body. You know, you see the sun, you see the moon, and the planets and the stars. They're all celestial bodies, but the Earth also is. And you realize that when you're outside of it. Fascinating.
So 2 of your 4 space missions were science missions.
Yep.
What kind of space findings did you come back with?
Well, we tested a method to generate electricity without using solar panels, using the so-called induction effect. If you have an electrical conductor moving rapidly in a magnetic field, you generate a voltage. And then if you can close the circuit, and we close the circuit via the ionosphere, because we were not in the real vacuum, we were in the high ionosphere, which is made of charged particles, so we were closing the circuit this way. And we could generate electricity with a cable moving rapidly in the geomagnetic field. So that was quite an interesting finding. And as you know, an electric motor, an electric generator is basically the same principle. In the motor, you use electricity to make mechanical energy, and in a generator you do the contrary. You use mechanical energy to produce electricity. And we use a second principle to generate electricity, but it could be used as an electric motor in space. You could change orbit with electricity, pretty much like we try to do now with cars and with airplanes. Electricity is a wonderful source of energy. It can be used in space also to change orbit, and that's what we wanted to test, and it worked.
Another 2 missions were repair missions of Hubble Space Telescope. There was an optical problem that you had to fix. And thanks to you now and your whole team, we have, I think, 1.4 million of space images that Hubble took. And NASA just recently celebrated 32 years of Hubble observations. But how did this procedure go? How do you actually fix a telescope in space?
Well, yeah, an optical telescope has a so-called primary mirror, a secondary mirror, and then the image is formed behind the primary mirror. And the primary mirror, 2.4 meter in diameter, was a little bit too flat. Of course, it's a curved mirror. It was slightly too flat. And we could not change the mirror itself. 2.4 meter diameter in a big telescope, it wasn't possible. But we could use or install an optical corrector for the scientific instrument. And that's what we did.
How?
And we changed the solar rays also. But anyway, we did what we could do in order to restore the optical capability of the telescope, and it worked, and it was a huge success. And for the first 3 years of utilization of the telescope, it was not really useful because the pictures of the stars were blurred; they were fuzzy. And since our intervention in December '93, pictures were really sharp, and the telescope became a hugely productive scientific instrument. So it was very rewarding for us and rewarding for the whole team that had worked on it. Yeah, it's not easy to work in weightlessness because, floating free, and you always need to attach your body to structure. Then you can use the other hand to work, or you can put your feet on a platform so that you can use both hands and both arms. We need to train a lot to do that. Do major repairs on a complex scientific instrument in the space environment was a real challenge. And it was the first time that we did that on our first visit to Hubble in '93. That was really a kind of a pioneering job because we had never done that before. We practiced that a lot in the water to simulate weightlessness in simulators, and it worked. And it was wonderful.
Great. But how was life in general during those 10 days in spacecraft? On one hand, you'll work in wonderful conditions, you have this starry view, and on the other hand, there is this unimaginable pressure to finish all the work on time and go back home safely.
Well, you need to put your priorities, and the priority for us was to be successful on the mission, to do what was expected of us. Of course, it's difficult because you work in an environment that is, on one hand, difficult, as I mentioned before, because of weightlessness and vacuum. The view is superb, it's beautiful, and this is kind of a distraction. But you need to focus on the job, and sometimes during the spacewalk, I remember you look for a while, wow, this is the Red Sea, this is the Gulf of Aqaba, this is the Gulf of Suez, and this is wonderful, this is beautiful, but you need to continue working. But it's hard because it's so beautiful. You would like to stop and just have a look at the beauty of the stars and also of the Earth.
But besides being an astronaut, you're also chairman of the board of directors of the Swiss Center for Electronics and Microtechnics. And CSEM researches the LISA system, which is a laser interferometry space antenna.
Yes.
So why is it relevant for space exploration?
Well, LISA is a program for the future. I mean, this is a preparation for LISA. The idea is to do interferometry to detect gravitational waves. And gravitational waves are emitted by celestial bodies that are very massive, and when there are changes, for instance, the merging of two black holes generates a lot of gravitational waves. And this is a new area of astronomy. You have optical astronomy, you have UV and gamma rays and infrared and radio astronomy, and gravitational wave, that's a new area. And when we can observe celestial objects with different methods, we learn more about the celestial bodies and what's happening. And that's the goal. We try to understand the universe, and gravitational wave is one way.
And you're using a lot of robots and props, for instance, around the moon, but we don't get to see many human beings. Why is this so?
Well, the moon program was about 50 years ago, the Apollo program. In fact, there was a political objective for the Apollo program. We had the early successes of the Soviets, and in this Cold War climate between the US and the Soviet Union, the Americans had to do something very spectacular and difficult, and the next step was going to the moon. They did that, but the goal was essentially political originally, and there was this decision of President Kennedy where to go to the moon in this decade, not because it is easy, but because it is hard. That goal will serve to organize and measure the best of our energies and skills. I mean, there was a huge will of Americans to beat the Soviets in this next step in space exploration. So in a way, the goal was reached with Apollo 11 in July 1969
and ever
with
since.
Neil Armstrong and Buzz Aldrin. But of course they had prepared all these programs, they had built the rockets, so they continued until Apollo 17 in December 1972. They could have continued a little bit, but it couldn't continue for a long time. It was very expensive. The goal was reached. Of course, we learned a lot from a technical point of view, scientific, but the main goal was to beat the Soviets, and it worked. So there was no reason to continue. It was very expensive.
All right. But speaking of expensiveness, what do you think about space tourism? How do people with money get along with people of science? Are they as responsible as professionals?
I think it's okay. I mean, the idea of space tourism or the involvement of a private astronaut, I think is okay, because going in space is such a deep experience and adventure that it's not right that it's only reserved to the professional astronaut. To open it to non-professional astronaut, I think is right. Of course, it's very expensive. You know, I was paid to do the job, a normal pay like an engineer, and that was fine. And of course, I had huge satisfaction doing that. Now, of course, the space tourist or the private astronaut have to pay to do that, and now it's pretty expensive. Typically, a flight of a few days on the Crew Dragon of SpaceX costs $55 million, so it's pretty expensive. But I think it's okay. The price will go down. It's like in aviation. You know, if you had to go from Paris to New York in the early 50s, it was very expensive. It's much less expensive now. The prices will go down. But the general idea of giving the opportunities to non-astronauts to go into space, they need to get still some training, but not a lot of training, I think is right. And I think there is mutual respect between the ones who go into space as a tourist or private astronaut and the professional astronaut. I think we need to work hand in hand. It's opening an opportunity for non-astronauts, and I think that's right.
But what about human settlements? Is this a probable scenario in the near future?
Well, it's going to be really hard to live long-term on another celestial body than the Earth. The Moon is going to be relatively easy because it's so close. But if you go beyond the Moon, it's very far away. Mars is about 8 months away. But it's not impossible that someday we have some human settlement there. But first we need to explore planet Mars. I think life on planet Mars is going to be really hard. And it's okay for explorers. Explorers, they don't look for comfort and luxury. They are ready to take challenges, even risks. Some of them may die, because again, it's a very tough environment. I'm not convinced that we'll have huge space colonies on Mars in the near future. 200 years, 500 years maybe, but not in the near future, because again, life will be really hard on Mars. It's going to be extraordinary, you know, as an adventure. But if you have 1 million people, you don't have 1 million explorers. You have 1 million normal people. You need hospitals, schools, you need all of that. And that's going to be an infrastructure that will be hard to set up. I see a lot of exploration of Mars and maybe other celestial bodies like Titan, a satellite of Saturn, or Europa, a satellite of a Jupiter. Really interesting bodies, but in the far future, not in the near future.
And you mentioned trainings. How important are trainings for private astronauts, as they call themselves, and of course for professional astronauts?
That's a good question. In fact, the training is related to the level of responsibility. And the commander of a mission has a lot of responsibility, trains a lot, and the pilot or the co-pilot, and all the ones who do spacewalking or who do scientific experiments or fix systems, they have a lot of training because they have responsibilities. A private astronaut normally doesn't have a lot of responsibilities. He goes for him or herself. Maybe we'll be doing some experiments or talking to school children, and they do good things. It's not entirely selfish. They share their experience, but they have relatively little responsibility, so they have not too much training.
In recent years, we had several groundbreaking findings when it's up to space. So what is the future of space exploration? Why is it still essential for humankind and solar system?
Well, I think it's really opening huge perspectives for humans. On one hand, as I mentioned before, seeing the Earth from above, to see how small the Earth is, how fragile it is, and to see also the changes that humans are producing on planet Earth. See this from space is really useful for the future protection of our planet. And I think the other aspect, looking out, looking at the sun, looking at the planets, at the exoplanets, at stars, galaxies, black holes, and all these objects, we learn so much about the universe. And the universe is a huge laboratory that provides conditions that are impossible to reach on Earth in terms of temperature, chemical composition, nuclear reactions, and pressure. All these factors are completely different and with a much wider scope as what we have on Earth. So it's a wonderful laboratory for science, and we'd better observe it to understand science on one hand, but to understand the world in itself, understand our past, our origin. We look at our origin. When we look at the galaxy, which is very far away, we see it as it was billions of years in the past. So we learn about the evolution of the whole world. This is fascinating. So it's for the mind, for the spirit, it's fascinating, and it's very useful when you look at our habitat, planet Earth, and help to better protect it for the future.
And what with Artemis project? When is it planned to be launched?
Yeah, this was launched by the US a few years ago. I mean, the plan to go back to the moon, Artemis projects, and the goal is to have an American woman set foot upon the moon in the South Pole in 2025. Maybe it's going to be delayed a little bit. And then, of course, there will be men also going on the moon, not only women. But the idea is to put women on the moon because men have gone there. In fact, we had a total of 12 men who walked on the moon in the Apollo program, Apollo 11 through 17 minus 13, where they didn't land. Now they want to have a woman on the moon, which is right. And then the idea is at the end of the 20s to have a moon base on the south pole of the moon. This is the moon, the South Pole. The advantage of the South Pole is that you can always see the Earth and you see the sun. Problem is if you are somewhere in the medium latitude, the moon rotates around itself in 28 days. So you have 2 weeks of sunlight, and then you have, which is fine, then you have 2 weeks of darkness, and it's very cold. If you're at the South Pole, you can always have a look at the sun and the Earth. So that's a good idea to go to the South Pole. So a woman, American woman on the moon on the South Pole in 2025, and then there will be a moon base, and you could go there. And you know, everyone listening to us could go there to the moon in the next few decades on that moon base on the South Pole.
Amazing. But we talked a lot about space exploration being at service for humanity. But how did these space missions serve you as an individual? Did they change your life on Earth?
Well, I mentioned awareness before, and it made me very aware of a lot of things. And you gain an awareness, again, about the planet Earth, the fragility, how small it is. You go around it in an hour and a half. That's a very, very short time. And of course, you go fast, but 28,000 kilometers an hour, which is our orbital speed, seems fast, but it's a small speed compared to other cosmic speeds. You know, the Earth goes around the sun much faster than that, you know, 30 kilometers per second. So it's fast. And you realize the Earth is so small, so fragile, so isolated also. I remember seeing it from space. Of course, you have the moon, you have the sun, and you have other celestial bodies, but I had the feeling of isolation of the Earth. And it means that we, inhabitants of planet Earth, about 8 billion people now, we have this responsibility because nobody will help us if we make a mistake. And we tend to make mistakes, so we'd better be careful. So for me, personally, the awareness of the beautiful world on one hand, the cosmic processes in the universe, and our fragile planet Earth, this was for me a huge enrichment.
Is this the reason why you're still very active, motivating and recruiting young professionals and not so young professionals to join space community? And is there a rise of interest in that?
I would say there's a rise in interest, yes, definitely. What is interesting is that during the pandemic, which lasted 2 years and still is existing in some countries, a lot of the businesses and activities of humans went down. But space was very productive during that time. So it's really, people were, of course, wearing masks when they were preparing these missions. But space has been extremely active for the last few years. And of course, the involvement of private companies like SpaceX in the US has been a huge, has had a huge positive effect on the popularity of space. On one hand, allowing the flight of a private astronaut, and on the other hand, rising the motivation of many engineers and scientists because they joined private companies. Many of them preferred not to work for the government, but for a private company, which is okay. It's a choice of everyone. Space is hugely popular right now, and it's good.
Well, Claude, thank you for your time and for talking to Al Jazeera.
It was my pleasure. Thank you.